Hey, we're taking a look at solving equations today, and I wanted to kind of simplify it here first for you in just a few basic steps that you're going to see again and again and again as you work with solving equations now and in the future. First, it's about kind of determining what the pieces are, what you're working with. So I've got three things here, which your book actually kind of outlines for you in a literacy link. The variable, and then in this example they give us, they say D is our variable, right? That letter, that unknown, we're going to call it a variable. We're going to be working with a numerical coefficient, so in this case the 1.2 is the number of variables we have, right? They say it multiplies the variables, so in this case we have 1.2 D's. 1.2 is our numerical coefficient. You'll see that today, you'll get to know that today. And then a constant. And in this example again we have two constants. That 3.5 is a constant, that negative 1.6 is a constant. They're not going anywhere, they're not changing, they're just there. Right? They're just pieces. They're unattached from the variables. They're on their own. So first, it's kind of about determining the parts. That's our first step. You're going to see that again and again today. And then using opposite operations to isolate variables, or we could think get variable by itself. Excuse me here while my... Okay. Get the variable by itself is what we could be thinking. Over here on the right, again in your text, from your text as well, I should say, opposite operations. So addition and subtraction would be opposites, multiplication and division would be opposites. You could refer to these as inverse operations. So we're going to see that a few times today, and I wanted to first give you a visual here. This is what this is going to look like. If we had 2x plus 1 equals 3, our goal is to get x by itself. Oh, look at that, we're rearranging this guy. So we've set this thing up. First thing we're going to do to both sides is we're going to take away 1 on both sides. So let me just get my keypad out here. I'm going to subtract 1 from both sides. There it is. Now I have 2x on the left and 2 on the right. And you'll see we're balancing both sides here. That's the beauty of this visual, is we're trying to keep the two sides balanced. Now we need to divide both sides by 2, right? I want to split these x's up. I want to get x by itself, divide both sides by 2, and there we go. We've got x equals 1. That's what we're left with. Let's try another here on the scales. 3, I'm going to give us one that's, well, let's just try another look, because that one's a little harder to play with, but this one we can kind of play with right on the screen. In this case we have 2 x's, but we can do the same thing. We can take away some 1's, and now we've just got x's by themselves on this side, and now we could add some x's. There we go. I added x's now to the point where I just have x by itself on the left hand side and 4 by itself on the right hand side. So we're going to get to know kind of how these guys work, how they behave, what to do with them, and you can play with some of these equations. Where's another nice one we can work with? Let's work with this one. If we add some 1's here, we've got 3x plus 4 on this side. And if we want the x's by themselves now, I can start adding some x's. And there we go. I've got 1x by itself, and I've got 4 on the other side. You'll see we're working with positives and negatives here, but the goal is always that balancing. Whatever we do to one side, we have to do to the other side. And we're using opposite operations. So here's what this looks like mathematically if you weren't feeling that. In this case our coefficient is 2, our variable is x, so if we divide by 2, or we could write it like this. If we divide by 2, then these are going to cancel. We'll get x equals 3/4 divided by 2. We could write that equal as 3/4 divided by 2 over 1, and then to do our division with fractions, we're going to multiply by the opposite, right? Multiply by the inverse. So x in this case equals 3/8, and there's our answer. So there's that opposite operation. We had 2 times x, so we divided by x. We use those opposite operations to cancel that and to get x by itself. And then it was just a matter of working out our math to get the answer, right? To find x. The next one here, we've got x, we've got m as our variable. We've got 3 as its coefficient. So in this case, we're going to multiply by 3. Those are opposite operations. sorry, multiplied by 3, and those are going to cancel, and multiplied by 3 on this side. So now we've got m equals negative 2 over 5. I'm going to write my 3 as a fraction to do my multiplication step. Negative 2 times 3 over 5 times 1, m equals negative 6 over 5, or we could write that as negative 1 1/5. But either way, we used an opposite operation to get m by itself, and then we just did our math to solve for m. Alright, you're going to see some uglier guys here, like this next one. We've got some fractions on both sides now. We've got some improper fractions to work with, so I'm going to rewrite this as negative 5 over 2, k on the left, so my numerical coefficient is now an improper fraction, and I'm going to rewrite this as 7 over 2 on the right. And now it's, again, this is the coefficient, it's multiplied by the variable, so we're going to divide by negative 5 over 2. And you might not love seeing it written that way, but basically what we're doing is this, negative 7 over 2, we're dividing by negative 5 over 2. And hopefully you remember now our step with our fractions is to flip and multiply, and we got to keep track of that negative, right? That 5 over 2 is still negative. So in this case, I'm going to use this cross-canceling method to get right to a simplified answer here. We've got negative 7 over negative 5, which just reduces or simplifies to just 7/5, or we could say that's 1 2/5. Okay, so some ugly math, but the same step, right? We had a coefficient multiplied by our variable, so we divided to get rid of it, and then we got k by itself. There's k by itself, 7/5. In the last one here, I'm gonna, let's say we're maybe shopping for Steve's wife here. She's buying this North Face coat. Apparently it's 25% off. Apparently the price is $109. What does that mean? How much is this thing actually worth, right? So now we're gonna use that first step. We're gonna kind of determine the parts of the equation, or figure out where to put our variable. So here's our situation again. In number 4, we've got this coat. It's 25% off the regular price, and the new price, or the sale price, is $109. So we can imagine that what's happening here is we had 100% and we took off the 25%. So that much of the regular price equals $109.99. And I'm trying to kind of take that word problem, I'm trying to write it, or take that math problem, I'm trying to write it out using words, so I can kind of see what's going on, so I can understand it mathematically. Now I could also say that if I take this, we had 100%, we took off 25, well actually that's now 75%. So 75% of the regular price equals this sale price, this $109.99. And this is where we need to use our variable. We don't know the regular price. So 75% of x equals 109, whoops, 109.99, or 0.75 of x equals 109.99, right? And now I'm just rewriting my percent as a decimal, and to do that I just divide by 100. And hopefully you remember that if we're talking about a percent of, or a fraction of something, we're actually multiplying those things. So 0.75x, 0.75 is our coefficient now, 0.75x is actually equal to 109.99. And now we've just got that kind of, that equation, just like we've been seeing it all along. We've got a variable, we've got a coefficient, we've got an answer, we've got a constant on the other side. So to solve this thing now, we divide by our coefficient. So now these are going to cancel, right? We just used an opposite operation. 109.99 divided by 0.75. Now again, you can write that however you want. X is going to be equal to $146.65. So in this case, the trick was at the beginning. We're trying to get to here, trying to get to our equation. Used an opposite operation, right? These were multiplied, so we divided both sides, right? That balancing thing, and we got to here. Now in your book, you're going to see these represented with number lines. If that helps, if you're familiar with that, take a look at that. If not, go back through the video. Just check out some equations again. See what's happening here. You might want to go back to the beginning and watch the part where we're playing with the balances and see if that makes any more sense to you. how we're using opposite operations in those cases. But ask some questions, try some questions, read some examples in the book, and then go ahead and move on to the assignment if you think you're ready to go, you guys. Good luck.